All right, everyone. Now that we've got go ahead and get Azure. We've got the lecture wrapped up. Let's go ahead and jump over to the lab, and for that, get Azure Data Studio up and running. Just go ahead and type and get Azure Data Studio going, and then I've already got it up. So I'm going to jump over to Data Structures Part 1. And this is going to link up to your workspace, your new IML workspace. So this is week two's, so 5, 6, 7, and 8. Remember, make sure this workspace is tied to your GitHub, and we're going to jump into notebook async number 1, where we're going to work with lists, tuples, and then we'll have a section for you to try here by doing a few things. Okay, so exercise number 1, working with lists. Let's go ahead and get this going. So the first thing I want you to do is we're going to create a list, use square brackets, and this is what we saw in the lecture. You have to use square brackets to create a list. You've actually seen this to a certain extent already, but let's create a basic list and then just build it from there. Right now, I'm gonna instantiate an empty list, and let's just do this. So we're gonna create an empty list, and from here, empty list. Let's print the list just so we know, and just to confirm that it is in fact empty. So we have an empty list that looks good, and let's populate it with some data now. So I'm going to create a mixed list, my list, and then I'm going to make that equal to 1, 2, 3, and then I'm going to say example. And this is something that we haven't seen. That we haven't seen up to this point, is that you can actually make lists, in this case, mixed. They don't have to always be numeric. Not all the data in a list has to be numeric. They can be mixed. So I can have in here, I have a combination of creating list data with multiple data types. I have integers, I have a string, and I have a float, all in a list. So that's kind of cool. Let's see what this looks like, and don't take my word for it. Let's make sure it works. List, and then we'll print that out, and there we go. Perfect. So that is an output that is mirroring this, and that's the basics of creating a list. So now let's do the same thing. Let's bring this down here. Let's create another one just to kind of save ourselves some time. Let's create we're going to use my list, and then we're going to 1, 2, 3. And then here, we'll say create list. This isn't an empty list. And then we'll print my list just to make sure we've got a new one. That looks good. And so now one of the questions comes up is in terms of mutability. Lists are mutable versus immutable, like we had discussed in the lecture. So let's talk about how we can make adjustments to this. And the first thing we're going to do is we're going to add elements into the list. And for this, I'm going to do my list. And what we have is we're going to use what's called the append, extend, or insert. These are different methods we can use to add or extend a list, but let's just go see what that looks like. So there's a method. So all you have to do is mylist.append, and then what we'll do is we're going to say 555, comma 12. We'll just add just random stuff here, and what this is going to do is add as a single element, and then let's run this. We'll do another print my list, rerun that. And here's what we showcased. I think it may have been dictionaries, but here we're showcasing that not only am I appending to the list, I'm nesting a list within the list. So I did an append of another list that I can now access. And again, this gives you a lot of capability to make multi-dimensional. You saw this in action in the very first exercises we were doing by creating multi-dimensional arrays. Or matrices, and then multiplying them times each other. This is a way we can do that. And this is how we would set that up, rather. But we're not doing that here. We're just working with lists. So let's now what we want to do is, let's say I want to extend my list. So I'm going to use a my list, and just like it sounds, I'm going to do a my list dot extend. And what this does is I'm going to just do a more examples and just show you what ends up happening here. More examples, and add as different elements. And let's see, hashtag, I need a hashtag. Yep, and then we'll rerun this again. And then we'll kick that off. And what we're doing is, this is a little different because the extend adds them as individual, it's not adding it as a single element, a list within a single element. That's not what's happening here. The extend just adds these into individual cells. And so you can see kind of how the difference between what an append does and an extend does. Now, if I did the append with just a single element, it would have done the same thing as extend, essentially. So there's different ways to approach this, as always, but you can mix and match these just to tailor towards your situation and what you're trying to do. Now let's do an insert. My list dot insert, and we're going to do an insert. Insert. And then in this case, we're going to put a 1. We're not going to put a brackets around this. We'll just say insert example. And this is going to be add element. We'll run this. Oh, wait, we need to print it. Print. And then run that. And there we go. And so what this does is it inserts it into element in the beginning. So it just inserts it. It doesn't append it to the end. So an append and extend adds it to the end of the list. The insert is gonna put it into the beginning, and you see where it's one insert example, and we just keep building it. So this is just a way to get, again, just to kind of get you familiar with what to do. And when it comes to adding elements into a list. Next up, we've got, let's see, we're going to delete elements of a list. And let's see, how do we do that? Removing. So removing elements. All right, so now let's do my list. Let's just grab, we can just grab whatever we want here. Let's restart up here. This is a good one to go with. Let's copy this down. Okay, and save us some time. And then I'm going to add a couple more things to it. I'm going to say 10 and 30, and we'll just create a couple more elements. And then from here, let's do a print of my list. And that gets us a starting point. Perfect. That means our my list is capturing the latest data. Now, let's say I want to delete an element within the list at a specific index. So the easiest way to do that is a del my list. My list 5. And what this is we'll run this again. And so this is going to delete element at index 5. Okay. And then if you look, it shortened it. 1, 2, 3 example. So 0, 1, 2, 3, 4, 5. So at index 5 is the 6th placeholder, because remember, the 0 place is the first position. So it's 0, 1, 2, 3, 4, 5, 6. So we deleted at index 5, and then that made the index smaller. So perfect. Okay, excellent, excellent, excellent. Okay. So then the other thing you might be tempted to try is make this like, is that a method or is that a delete? What is that? So it's kind of, it's an interesting way to delete elements, because if you can try it, it's not going to work. It's not a method, so, and it's not like some kind of typo type of thing. It's actually it's its own command for my list, so you can do a delete on my list at that index, and it's pretty nice, and that's meant to be a function of Python being kind of easy and readable and kind of more English, natural English language style. So we did a delete within the my list at 5. Let's go and move on to a remove. So now we're going to use what would be called the more traditional, I'd say the way you'd see inserting data. So we'll do a my list dot remove. And then in this case, you can actually name out exactly what you want to remove. And so we can remove an element from within the list by just its name. So we can say my list dot remove example, and then remove element with value. Yep. And then print my list again. Whoops. And then rerun this. All right, there we go. So then that removed, you can see here, it kicked the example out. Let's just keep this rolling. Now what we can do is we can pop an element from the list. This is a pretty, I would say this is one of your more popular ones. So I'm going to do, and I'm going to write this out to another variable. So I'm going to say a equals to my list dot pop 1. And so what this is going to do is it's going to pop element from list. And let's do this, and we'll say, oops, man, I'm just hitting the @ sign like crazy. Okay, and then we'll say print, I'm going to say popped element, just to kind of give us some practice, element, and we're going to concatenate, we're going to, actually we just say a, it's just easier for typing, list remaining, and then my list. And I think that's all we need. All right, let's run this. And let's see where I messed up. Oh, comma. There we go. Run that again. Oh, I'm still missing. I'm missing another comma. Missing a couple commas. There we go. Okay. So popped element to list remaining 1, 3, 3.31, and 30. So here we go. Element 2. We don't need all that. I put too many A's in there. Okay. Let's see. Popped element 2, list remaining 1, 3. There we go. That looks good. So we removed that and read it out to another list called A, and then we showed the list remaining my list, which is fine too. This is just an example of how you can. I made a copy of it so that I could just show what we popped out. So so my list.pop 1 was pulled out to A. It's popped out, so you removed it and we pushed it into another variable. So it's kind of cool. It's a neat function, and it is used quite a bit. All right, now next up, you probably want to know, how do I? Here we go. Let's see, how to remove, like, get rid of everything, everything in a list, like completely truncate a list. So in this case, we use what's called the clear function, my list, or clear method, my list dot clear, and then what this is going to do is it's going to empty the list. Empty list, and then we can do a print my list again. My list, come on, wake up, my list, and then what we should see is an empty bracket. Yeah, just like what we did when we instantiated up here, we got an empty bracket, so that looks good. All set. And now I think what we're gonna do here next is we're gonna show we're going to show how to go through and access all the elements, index the elements. There's a couple extra things we're going to do. A little bit of control flow on this list, and just to kind of keep it all kind of fresh for everyone. Let's copy this down again because our list has been completely obliterated. And then what we're going to do is create a for loop. So we're going to say for element in my list. And then we'll say print element, element. And again, we've done this already. So then that gives us iterated access to the individual cells. And then if I print my list, right, this gives us the normal way we've done it. So run this again so we can see the differences here. And then this is access, and so let me annotate this a little bit. So this is access elements one by one. Now we're familiar with this one. This method is access all elements at once, which is what we've been doing. And then let's do print, and then my list, and then this is access the index. So I'm gonna say 3. And then we'll say access index 3 element, and we'll run that, and then you can kind of see what's happening here. I'm just I'm just accessing the individual cell from that index 3 or element. Okay, now next up, I'm gonna do this. Save myself some time. Access access elements in a range. Elements in a range. Okay, and to do a range, it's 0 to 2. This is, and I'll run this a couple times. So this is going to give us access from the first position to the it goes to only shows the first 2. But if I wanted to get 3, for example, I would say 3, and then that's going to give us 1, 2, 3. And then if I wanted to only access 2 and 3, I would do that. So this gives us an ability to access the entire set. Now, if you want to, for example, you can also do things like this. I can say 0, start from 0 over, and then give me everything past that. In other words, I can start at the position 3, and then it would give me everything to the end. On the flip side, I can do nothing to 4, let's say, and that gives me the start position to that index. So that's something that you want to. It's very nice. List and ranging, you have a lot of capability here. So I'm going to go back to 0 and 2. You can play with that a little bit more. Next up, access elements in reverse. This is a neat capability. Access elements in reverse. So this is, I can do -1, and let me, -1, print my list. Let's do this again. Access elements in reverse. There we go. Okay, so then in this case, what this does is this gives me an ability. I can back up 1, oops, I've got 0 in there. What am I doing? 0, and take that out. There we go. So what this does is it reverses the data set. As you can see here, what this gives us the inverse of the ordering of the initial list. So the way this was laid down, it's done in the opposite. Okay, that is all we have for lists. That's quite a bit. We blasted through a lot here. Now we're going to jump over to tuples. Tuples are quite a bit easier to work with because one, we don't have all the mutability that we have to work with because tuples are ordered but immutable. So the functions that we have to available to us are not quite as expansive. So that's okay. Let's take a look at this here real quick. We use them for different purposes, but same as lists, the data once entered in a tuple cannot be changed, right? That's the mutability. And there is an exception. You can't once data inside the tuple is mutable only when the tuple data can be changed. So there is kind of some gray area with tuples in that, and I'll show you what that looks like. But for the most part, and for us, just know that tuples, by and large, there's only this little one exception that we have to kind of contend with. But for the most part, for all intents and purposes, tuples, they are immutable. All right, so let's jump into creating a tuple, my tuple. And then we're going to do 1, 2, 3. We're going to create a tuple, and then what we're going to do is print my tuple. All right, and there we go. That's as easy as that. Now, from here, we want to, let's say we want to access elements in the way that we did with lists. So let's just do that like we had done up here. We're going to go through this exercise, same style. So let's do a my tuple, and then I'm going to actually copy this down. I'm going to create a new tuple, my tuple 2, and then let's do Eureka. Eventually get there. And then my tuple 2. And run this. All right, there we go. Now we've got 2. This looks good. Okay, so let me show you. Let me show you something here that relates to some of this. Before we jump into this, so I've got my new tuple. Oops, tuple 2. There we go. And then tuple 2. All right. And then up here, so this is kind of our starting spot right here. So we're good. This is my tuple 1, 2, 3, and then my tuple 2. And let's talk about this real quick. It says the only exception, right? So when we're talking about Python and tuples, there is an exception to being able to do some mutability within a tuple, but only if that the object inside the tuple is mutable. And what they mean by that, and just to show you, is I can create a tuple like this, and I can just show you here, and then I'll back it off. So I can create a list within a tuple, like this, and then I can print this off. What they're saying and what the rule is with working with tuples is these parts of the element. So this right here is immutable, but because I buried a list within a tuple, remember, data sets within Python data structures can be nested. So in this case, I nested a list within a tuple, which is accessible, and I can pop, like for example, I can pop elements in and out of, or I can remove lists, elements within a list within the tuple, but I can't outside of that. So for example, let's say I wanted to delete 1. So I did, like, for example, remove, which is a method that exists for us in lists. So here, I'm just for kicks, if I wanted to say my tuple, tuple dot remove 1, and I run this, let's say, I'm going to get an error because that actually, a tuple, that doesn't have an attribute for being able to remove that. So there's things we can do, but we're limited in terms of the operations. Again, back to that mutability aspect of a tuple, or rather an immutability. All right, so let me get back to getting us where we were before. So I'm going to rerun this so that we're back to normal. We got our normal tuples. Good. Okay. Now let's go ahead and wrap up tuples, and that should be that'll be it for this lab. Okay, so we're going to do a 4x in my tuple, so we can iterate on these. These are iterable objects. So I've got that. There's no gotchas here in terms of what you're going to come across. They are iterable, so I just iterated on tuple 2. Tuples are iterable, just like lists. Okay, and then they're same access structure. So we've got the print my tuple. Same access like lists, right? And then I can do similar here where I can come in and access an index. So I can say 0. And let's run that and see what that looks like. So there you go. Gets me the first position. Then by index. And then let's say I want to do ranging. I can do that too, right here. All right, that gives me again, we can do 1, right? Same thing. Range by lists by index. Let's see, what else can we do? We can also do this too, which is we can access it this way, which is 3. Let's say 3. We can bracket this by 3 and 4, and let's see here, and that gives us this interesting option. Now, this is something we didn't do in the list, but access element and index within element. Okay, so I created a tuple, right, and then we baked in this Eureka, and then so I'm saying within my tuple now, I've got 2, 3, and so within, I'm sorry, 1, 2, 3, and 4. So in the third index position, I'm able to access the which would be K within that index element. Okay, so what we're doing is there's so if my tuple 2 has 1, 2, 3, 4, right? I'm going 0, 1, 2, 3. So that's what the 3 represents. And then the 4 represents the 0, 1, 2, 3, 4. So it's pulling back the K position of my tuple. So that's accessing an element or a cell and an index within that cell. Or in this case, using Python's terminology, an element. So an element and an index within the element. That's a neat feature, and definitely it comes in handy being able to know how to manipulate these data structures like this. It's super helpful. Okay, now that we've done that, let's go ahead and we have an ability to we can use the plus. So if we've created 2 tuples here. We've got my tuple, and then we've got my tuple 2. And let's say I want to create. I can append. So I can just do an append tuples. There is a way to do this. I can combine them, and so I can say my tuple, and then let's say equal to my tuple. So this is the one from above. So this is 1, 2, 3. And then my tuple, I'm going to read it back to itself, and then I'm going to combine another tuple to it. So I can say 4, 5, 6. add more to tuple. Append tuples, then print my tuple. Let's see. I'll get myself in trouble here. My tuple, and run this, and there we go. Yep. So that worked out just fine. We can use the concatenation operator here, which would we can add these elements and create a bigger tuple. Okay. Now you might be asking, like, what's the difference if excuse me, that if a tuple is immutable, how is it that I'm able to add to the tuple? So you can add to it, you just can't change elements within it. That's the thing. So for example, I can't, once I've created 1, 2, 3 in the tuple, I can't change 1, 2, 3 in the tuple. So I can't change that. But I can add to it so that I can create and make tuples bigger. I can append to them, but now once I've done this, my tuple positions 1, 2, 3, 4, 5, and 6. Those elements are not. I can't change those. So that's the difference, right? In terms, when we talk about immutability, it's the changing of cells. In this case, I'm not changing, I'm adding. All right. Okay, let's see. With that, what else do I have to show here? I think I got a couple more things to show. Let's see. All right. We've got we did the append, and then I think the last thing I want to do is some functions that I want to show in terms of how similar lists and tuples are. Okay. So these functions are the same as they are for lists. Okay. Now I'm going to do the my tuple here. So we did this. I can do a my tuple equal to. Let's see. I'm going to do another one. My tuple 3, and I'm going to create a new one up here. This shows that tuples can have mixed data, so I can do same as before. I can say, we can say, as an example, and here we go. All right, I can have mixed data sets, and then print my tuple. Tuple 3, whoops, 3, there we go. All right, there we go. So I can have mixed data types, that all makes sense. Now I'm gonna access, let's say, my tuple 3 and 0, and then equal to English, and we can do this. And essentially what that does is it actually describes the thing that we were talking about in terms of the immutability exception. That's probably the mutability exception that I was talking about. Since we buried a list within this tuple, this shows you how this right here did an update to the list itself. So and we went and did we replaced Hindi. So in the third position, we replaced this index 0 with English. And so the way to show that is rerunning the, so we'll rerun this, and then it updated Hindi to English. That is we can do an update of a list within a tuple, and again, that's back to that mutability exception because we are updating a list. Okay, now let's see. With that, I think I only have a couple more things to do, which is showing the ability to do, let's do a print. We'll do a print of the count and 2. These are just some little handy things to know about. So I'm going to run this. And what this is going to do is it just gives us a quick view of the basically of the oh geez, the easiest way to think of it, the number of times something shows up in a list. So in this case, when I do the count function, this does a count. It's kind of like the select count feature that you have, but with a where clause on it. In this case, it's all wrapped in one. So I'm doing a count within the tuple, looking for the item of 2, and because there's only one that shows, so there's only a count of 1 where 2 exists. So we have 2, which means that only shows up one time. If we put 2 in here twice, then this count would show up as 2. So this is find count of a given data search. There you go. That's probably the easiest way to say that. And last up is going and taking a look at if I want to, using the index method, I can come over here and let's do this, and I can do an index. We'll just run this and see what we get. Index, and then I can do English and Python, which is right here. I'm just going to copy this right there. And what this is going to do, if I run this, is going to give me the positions, the position of this, where this location's at. It's going to give me it's going to return the index of of within the tuple of where that's at. So in this case, it's 0, 1, 2, 3. So this is the index, the list for Hindi or English Python now exists within the third index position of the tuple. Okay, now that's all we have for this lab. That wraps this up. So next up, I want you to try this. So create a list of the English alphabet, then access and print the 10th letter in the alphabet, and then now do it over again, but instead of a list, do it with a tuple. So so basically just get some practice, and then this is you'll probably have to use some control flow. But anyway, take that with you. If you've got any questions, rather, if you've got take a stab at it, and then if you got any questions, give me or give your instructors a holler on Slack. With that, that's all we've got here, and I will see you in the next learning activity.